Learning objectives. In this chapter, the users would learn the following aspects of Pentium class processors: Pentium Processor, Pentium Pro Processor, Pentium Mmx Processor, Pentium 2, Celeron Processor, Pentium 3 Processor, Pentium 4 Processor. Introduction to Server Class Processor. Processor. The processor, which is a CPU central processing unit, is a computer's brain. A processor is the most important part in a computer system. A processor carries out certain instructions and manipulates data. It allows the processing of numeric data, meaning information entered in binary form, and the execution of instructions stored in memory. The first microprocessor, Intel 4004, was invented in 1971. It was declared as the world's first microprocessor. It was a 4-bit calculation device with a speed of 108 kHz. Since then, microprocessor power has grown exponentially. In addition, you have to consider the processor and the motherboard together when planning to buy the computer or laptop. A processor can only perform as well as the motherboard it's mounted on. So don't take immediate decision at the time of buying the computer, and if your budget requires you to cut costs, try looking somewhere else. There are many features that influence the performance of a processor: memory and power in computing, data bus width, processor speed, clock rate, I/O bus speed, cache memory. Classification of server processors. Though the architecture of the processors play an important role in determining the performance of a processor, the server processors are classified only based on the speed with which they handle a task. Based on the given factor, the server processors are classified into first-generation processors, second-generation processors, third-generation processors, fourth-generation processors, fifth-generation processors, sixth-generation processors. It is important to note that the classification is done by Intel, as they were the inventors of the processor. First-generation processors. First-generation processors were used on the earliest of machines, the original IBM PC and XT, and the first clones. These machines were primitive in most ways compared to modern PCs, and the processors they used were of limited capabilities. First-generation processors run at system bus speed and use the oldest processor technologies. Examples of these types of processors: Intel 8088 and Intel 8086. Second-generation processors. The only chip generally considered second generation is the 80286. Intel also made a chip between the 8088 and the 80286 called the 80186. Largely due to a lack of performance enhancements compared to the 286, in addition to compatibility problems with support chips, the 80186 was never really used in PCs. It has, however, found a strong niche role in the design of embedded microcontrollers. Even to this day, its example is Intel 80286. Third-generation processors. The third-generation processors, the 386 family, represent another step forward from the second-generation class. Intel started with this generation of chips to create subfamilies of related chips with different capabilities, using the DX and SX designations. Some of its examples are Intel 80386DX and Intel 80386SX. Fourth-generation processors. The fourth-generation processors saw rapid growth in the CPU's power and capabilities, and the introduction of several new technologies as well. It was here that AMD and Cyrix had their first real early successes in not just emulating Intel's designs, but coming up with real value leaders of their own at the top end of the fourth-generation scale. Also, it was at this time that the new phenomenon of upgradable processors and standardized motherboard sockets began to become prevalent. Some of its examples are Intel 80486DX, Intel 80486SX, AMD 5x86 and Cyrix 5x86. Fifth generation processors. The fifth generation of processors saw several changes from earlier CPU families, and several trends continue as well. Chips continued to get faster and faster, and architectural changes were made to increase overall system speed as well. AMD and Cyrix developed their own compatible processors instead of just trying to clone Intel's, leading to more variety and choice in the marketplace. The Pentium and the compatibles that followed it opened up the world of computers for millions of users and propelled computing to the next level. Some of its examples are the Intel Pentium P5, Intel Pentium Overdrive, Cyrix 6x86, and AMD K5. Sixth generation processors. New and innovative architectural designs are employed in these CPUs as it gets harder to continue easy performance improvements such as widening of buses and increasing clock speeds. Clock speeds do increase, but new ways of getting more done in each clock cycle are also the focus. The line between fifth and sixth generation is much blurrier here than between previous generations due to sixth generation chips running in fifth generation motherboards and the mixing of technologies between different chip families. AMD K6 and Cyrix 6x86MX are considered to be the sixth generation chips despite the fact that they run in fifth generation motherboards. This is based on assessing them technologically and in terms of the performance, along with when they were released to the market. Some of its examples are Intel Pentium Pro P6, Intel Pentium 2 Clamart, AMD K6 and Cyrix 6x86MX. Memory and power in computing. The amount of RAM in a computer can have an intense effect on the computer's power. If there is availability of additional RAM, it indicates that the computer can be used for bigger and more powerful programs with access to larger data files. More RAM also can make the computer run faster. The computer does not necessarily have to load an entire program into memory to run it. However, the greater the amount of program that fits into memory, the faster the program runs. A PC with a 16 MB of RAM is able to run Microsoft Windows 98 even though the program actually occupies about 195 MB of disk storage space. When you run Windows, the program does not need to load all its files into memory to run properly. It loads only the most essential parts into memory. When the computer needs access to other parts of the program on the disk, it can unload non-essential parts from the RAM to the hard disk. Then the computer can load other program data which is needed or necessary. This process is called swapping. While this is an effective method for managing a limited amount of memory, it can result in slow system performance because the CPU, memory, and disk are continuously occupied with the swapping process. If your PC has 64 MB of RAM or more, you will notice a dramatic difference in how fast Microsoft Windows 98 runs because the CPU will need to swap program instructions between the RAM and the hard disk much less often. Data bus width. In computers, the term bus means a path between the elements of a computer. There are two main buses in a computer: the internal or system bus, the external or expansion bus. The system bus exists on the motherboard and connects the CPU to other devices that exist on the motherboard. An expansion bus connects external devices such as a keyboard, mouse, modem, printer, etc. to the CPU. Cables from disk drives and some of the internal devices also are socketed into the bus. The system bus has two parts, the data bus and the address bus. The address bus leads from the CPU to RAM. The data bus connects the CPU to memory as well as all the storage, input, output, and communication devices. It refers to the size of the data bus in bits. When 8088 processor, the the first processor was released, the data bus size was of 8 bits. This anticipated that the processor accessed one character at a time. 8 bits equals one character every time it read or wrote data to memory. The processor makes use of the data bus to transfer data between it and system memory, RAM and ROM, and the secondary devices. The size in bits determines how many characters are needed to transfer at any one time. An 8-bit data bus transfers one character at a time, a 16-bit data bus transfers 2 characters at a time, and a 32-bit data bus transfers 4 characters at a time. This means that the processor is running at a fixed speed. Data transfer on a 32-bit data bus is 4 times faster than on an 8-bit data bus. Processor speed, clock rate. It means the speed of the clock that drives the processor. In the beginning, the 8088 processor was released at 4.77 MHz, which means the frequency of the signal that was applied to the processor. This signal is used to originate the timing functions that the processor needs to transfer the data. In common, the processor will execute the operations faster with a faster clock signal, which has higher means. Today, the Pentium processors run at speeds of 200 MHz or greater, which is significantly higher than previous releases. This enhances the presentation of the processor unit, which allows performing more operations per second. The number of operations per second is linked to the clock cycles, which is determined by the clock frequency applied to the processor. Input-output bus speed. It refers to the speed at which input-output bus secondary devices such as video displays and hard disks can run together. The original IBM PC ran the expansion I/O bus, which is also called as RSA 8 MHz, then gradually at later stages it got revised to 10 or 12 MHz. Other bus systems use diverse or different speeds to accomplish higher and faster data transfer times, which means more data per second. The need for high bandwidth is very much necessary for high-resolution graphic displays, sound, and video. The multimedia applications that demand high bandwidth cannot use the ISA bus, so it has been replaced by PCI, Peripheral Connect Interface, which is faster than ISA bus and delivers much faster data transfer rates. Cache memory. When the data moves between RAM and the CPU's registers, it is one of the most time-consuming operations as RAM is much slower than the CPU. A one-sided solution to this problem is to have a cache memory. Cache memory is exceptionally fast memory. It holds the most recently used data and instructions. When a program is operating and the CPU needs to read data or program instructions from the RAM, the CPU checks first to see whether the data is in cache memory. If the data is not available, the CPU reads the data from RAM into its registers and also loads a copy of the data into cache memory. The next time the CPU needs the same data, it finds it in the cache memory and saves the time needed to load the data from RAM. The data accumulated inside the cache can access the instruction at a faster rate by CPU than the data stored in system memory. There are 3 types of cache memory, which is L1, L2, and L3. The difference being the speed and size. L1 or level 1 cache is much faster but also holds a lot less data than L2 or level 2 cache. L2 is faster than L1 but not faster than L3. Since the late 1980s, L1 cache memory has been built into the CPU. The first CPU caches came with 0.5 KB, then 8 KB, then 16 KB, and then 32 KB. Today, many CPUs have 256 or 512 KB L1 cache built in. L2 level 2 cache can be built into the CPU or it can be built into the motherboard. The closer cache memory is to the CPU, the faster it is. Therefore, a CPU with both L1 and L2 cache on die will be faster than a CPU with its L2 cache on the motherboard. Many PCs sold today have 512 KB, 1024 KB or 2 MB of L2 cache memory. but in some of the modern processors, L2 cache is inbuilt, making the process faster. Parts of a processor. As discussed in detail in the previous slides regarding the characteristics or features of processor, there are different parts of processors and their usage. The different parts of the processor are control unit, ALUs, transistors, registers. Control unit. The control unit is the component of the processor. It directs and synchronizes most of the processor that directs and coordinates most of the operations in the computer. The control unit has a role much like a traffic light. It interprets each instruction questioned by a program and then commences the appropriate action to carry out the instruction. The control unit coordinates the input and output devices of a computer system. The functions performed by the control unit vary greatly by the internal architecture of the CPU. The control unit performs the tasks of fetching, decoding, managing execution, and then storing results. ALU. ALU stands for Arithmetic Logic Unit. It is another part of the processor which performs arithmetic, comparison, and other operations. Arithmetic operations include necessary calculations such as addition, subtraction, multiplication, and division. Comparison operations involve comparing one data item with another to determine whether the first item is greater than, equal to, or less than the other item. Depending on the consequences of the comparison, different actions may take place. For example, to determine if an employee should receive overtime pay, software instructs ALU to compare the number of hours an employee worked during the week with the regular time hours allowed, for example, 40 hours. If the hours worked are greater than 40, software instructs the ALU to perform calculations that compute the overtime wage. Transistors. Transistors are the elements of a microchip that receive and give out electronic signals to communicate data. If the computer has more transistors, the chip will operate faster. Many modern microprocessors feature millions of transistors that are used for simultaneously communicating a great deal of information and instructions all at the same time. The terminals in a CPU transistor have specific names depending on the type of transistor. The terminals of a simple bipolar transistor are called the collector, emitter, and base. The current or voltage that's applied to the base affects the current flow from the collector to the emitter. The voltage at the base of the transistor can be used to turn on and off the current flow from the collector to the emitter. Registers. A processor contains small high-speed storage locations called registers, which temporarily hold data and instructions. A register is a small set of instructions that a processor speaks. After the current process or instruction is processed, this knowledge is divided into different positions or locations on a microchip. It uses some registers to take instructions and some to store information to work on. Keep in mind that all of these tasks are happening at fractions of seconds. Register functions include storing the location from where an instruction was fetched, storing an instruction while the control unit decodes it, storing the data while the ALU computes it, and storing the results of a calculation. Pentium Processor. Pentium is a brand used for a series of x86 compatible microprocessors produced by Intel. The Pentium is a widely used personal computer microprocessor by Intel Corporation. First offered in 1993, the Pentium promptly replaced Intel's 486 microprocessor. It came as a microchip of choice in manufacturing a personal computer. The innovative Pentium model consists of two processors on one chip, which contains 3.1 million transistors. Pentium 2 Stars, in its most current form, a Pentium processor, is a consumer-level product that Intel rates as 2 stars, which means it is above the low-end Atom and Celeron products, but below the faster Core i3, i5, and i7 lines, as well as the high-end Xeon processors. There are different types of processors, which are Pentium Pro processor, Pentium 2 processor, Pentium 3 processor. Pentium Pro processor. The Pentium Pro, released in 1995, was designed to fuel 32-bit server and workstation-level applications which were needed for enabling fast computer-aided design, mechanical engineering, and scientific computation. In addition to the microprocessor, the Pentium Pro includes another microchip containing cache memory. The Pentium Pro contains 5.5 million transistors. The Pentium Pro included integrated 256 KB, 512 KB or 1 MB L2 cache running at the processor speed. The L2 cache in the Pentium Pro was not located on the same die as the CPU core. The Pentium Pro processor was the only processor from the Pentium 2 family that didn't have MMX instructions. The Pentium Pro can perform at nearly twice the speed of previous Pentium microprocessors. Pentium 2 processor. The Pentium 2 is a Pentium Pro with Intel's MMX technology included. It comes in microprocessor clock speeds of 233 MHz, millions of cycles per second, 266 MHz, and 300 MHz. It's suitable for applications that include motion video and 3D images. Among the Pentium 2's features are a 512 KB Level 2 L1 and L2 memory cache and a 32 KB L1 and L2 cache, twice that of the Pentium Pro processor. The L2 cache can include error-correcting code ECC. Celeron is a low-end Pentium without the L2 cache, and Xeon a high-end Pentium that replaces the Pentium Pro for enterprise server and workstation computers. Pentium Mmx Processor. Mmx is a Pentium processor from Intel that is designed to run fast when playing multimedia applications. According to Intel, a PC with an Mmx processor runs a multimedia application up to 60% faster than one with a microprocessor having the same clock speed but without Mmx. In addition, an Mmx processor runs other applications about 10% faster. The Mmx technology consists of 3 improvements over the non-Mmx Pentium microprocessor. 57 new processor instructions have been added that are designed to handle video, audio, and graphical data more efficiently. A new process, Single Instruction Multiple Data (SRMD), makes it possible for one instruction to perform the same operation on multiple data items. The memory cache on the microprocessor has increased to 32,000 bytes, meaning fewer access to memory that is off the microprocessor. Celeron Processor. The first Celeron processors were released in April 1998 at speeds of 266 and 300 MHz. Using Covington core based on Pentium 2 Deschutes core, these processors inherited most of the Pentium 2 features like dynamic execution architecture, MMX technology, and others. And as Pentium 2 processors, they were designed to work in slot 1 motherboard. At the same time, Celeron processors lacked some features of Pentium 2. There was no L2 cache. Dual processing and multiprocessing were not supported. Processor package was different. New package didn't have protective plastic case around the processor. Pentium 4 processor. Intel Pentium 4 is a family of high-performance processors that succeeded Pentium 3 family. Pentium 4 CPUs are based on new net-burst microarchitecture, which differed significantly from P6 microarchitecture used in Pentium 2 and Pentium 3 processors. As overall CPU performance is proportional to its frequency and its efficiency, to achieve better performance levels, many microarchitectures, including P6, strike a delicate balance between the faster CPU frequencies and improved efficiency. Pentium 4 brand was used only for high-performance single-core desktop and mobile processors. Hyperthreading technology was also initiated with the Pentium 4 processor. This technology allowed the single-core processor to act and function like 2 logical processors. This helped to increase computer performance and running more applications on a single computer. Server definition. A server is a computer or device that can manage all resources connected within a network. The server performs specific tasks and can manage, store, send, and process the data all through the day. The server is configured with a variety of features and hardware that are not typically used in the regular desktop computer. It is a system of software and hardware to develop a computer network to offer network service. In this, it is possible to provide several services by a computer and make several servers running. It operates within the client-server architecture to perform specific assignments on behalf of clients. But if you look at it from the perspective of Internet Protocol, networking, a server is a program that functions as a socket listener. Server. Special attributes. Server is of multiple types, and some typical computing servers are database server, file server, mail server, print server, web server, gaming server, and application server. Some of the hardware used in a server is form factor, processor, memory, and storage. The server operating system acts as a software platform on which the server programs run. Some of its examples are Microsoft Windows Server 2012 R2 operating system. Reliability and longevity are two factors that play a key role in the deployment and function of a server. In this, there is enterprise hardware, which is generally offered with a longer warranty from the manufacturer. The reason behind longer duration of warranty is the fact that the failure rate on server is very low. Types of server. The types of servers are based on various factors. So there are multiple types of servers or types of network servers. These are server platform. Server platform is the fundamental hardware or software of a system which acts as an engine that drives a server. It is often used synonymously with an operating system. Application server, also known as a type of middleware, it occupies a substantial amount of computing region between database servers and the end user and is commonly used to connect the two. Audio or video server. It provides multimedia capabilities to websites by helping the user to broadcast streaming multimedia content. Chat server. It serves the users to exchange data in an environment similar to Internet Newsgroup, which provides real-time discussion capabilities. Fax server. It is one of the best options for organizations that seek minimum incoming and outgoing telephone resources but require faxing actual documents. FTP server. It works on one of the oldest of the Internet services, the File Transfer Protocol. It provides a secure file transfer between computers while ensuring file security and transfer control. Groupware server. It is designed to enable the users to work together, irrespective of the location, through the Internet or a corporate intranet and to function together in a virtual atmosphere. IRC server. It is an ideal option for those looking for real-time discussion capabilities. Internet Relay Chat comprises different network servers that enable the users to connect to each other through an IRC network. List server. It provides a better way of managing mailing lists. The server can be either open interactive discussion for the people or a one-way list that provides announcements, newsletters, or advertising. Mail server. It transfers and stores mails over corporate networks through LANs, WANs, and across the Internet. News server. It serves as a distribution and delivery source for many public news groups, approachable over the Usenet news network. Proxy server. It acts as a mediator between a client program and an external server to filter requests, improve performance, and share connections. Telnet server. It enables the users to log on to a host computer and execute tasks as if they are working on a remote computer. Virtual servers. A virtual server is just like a physical computer because it is committed to an individual customer's needs, can be individually booted, and maintains privacy of a separate computer. Basically, the distance among shared and dedicated hosting services is reduced, providing freedom to other customers at a less cost. Now it has become omnipresent in the data center. Web server. It provides static content to a web browser by loading a file from a disk and transferring it across the network to the user's web browser. This exchange is intermediated by the browser and the server communicating using HTTP. Server processor. The server processor is a component that enables the server to perform its task. It provides a server machine with enough memory to prioritize the tasks that are requested by the user. Each server can be configured with a single processor or a number of processors that run in parallel to perform a task. Some of the examples of a server processors are AMD 64-bit ARM processor and Intel Xeon E7. Classification of server processors. Though the architecture of the processors play an important role in determining the performance of a processor, the server processors are classified only based on the speed with which they handle a task. Based on the given factor, the server processors are classified into first-generation processors, second-generation processors, third-generation processors, fourth-generation processors, fifth-generation processors, sixth-generation processors. It is important to note that the classification is done by Intel as they were the inventors of the processor. First-generation processors. First-generation processors were used on the earliest of machines, the original IBM PC and XT, and the first clones. These machines were primitive in most ways compared to modern PCs, and the processors they used were of limited capabilities. First-generation processors run at system bus speed and use the oldest processor technologies. Examples of these types of processors: Intel 8088 and Intel 8086. Second-generation processors. The only chip generally considered second generation is the 80286. Intel also made a chip between the 8088 and the 80286 called the 80186. Largely due to a lack of performance enhancements compared to the 286, in addition to compatibility problems with support chips, the 80186 was never really used in PCs. It has, however, found a strong niche role in the design of embedded microcontrollers, even to this day. Its example is Intel 80286. Third-generation processors. The third-generation processors, the 386 family, represent another step forward from the second-generation class. Intel started with this generation of chips to create subfamilies of related chips with different capabilities, using the DX and SX designations. Some of its examples are Intel 80386DX and Intel 80386SX. Fourth-generation processors. The fourth-generation processors saw rapid growth in the CPU's power and capabilities and the introduction of several new technologies as well. It was here that AMD and Cyrix had their first real early successes in not just emulating Intel's designs, but coming up with real value leaders of their own at the top end of the fourth-generation scale. Also, it was at this time that the new phenomenon of upgradable processors and standardized motherboard sockets began to become prevalent. Some of its examples are Intel 80486DX, Intel 80486SX, AMD 5x86 and Cyrix 5x86. Fifth-generation processors. The fifth generation of processors saw several changes from earlier CPU families, and several trends continue as well. Chips continued to get faster and faster, and architectural changes were made to increase overall system speed as well. AMD and Cyrix developed their own compatible processors instead of just trying to clone Intel's, leading to more variety and choice in the marketplace. The Pentium and the compatibles that followed it opened up the world of computers for millions of users and propelled computing to the next level. Some of its examples are the Intel Pentium P5, Intel Pentium Overdrive, Cyrix 6x86, and AMD K5. Sixth-generation processors. New and innovative architectural designs are employed in these CPUs as it gets harder to continue easy performance improvements such as widening of buses and increasing clock speeds. Clock speeds do increase, but new ways of getting more done in each clock cycle are also the focus. The line between fifth and sixth generation is much blurrier here than between previous generations due to sixth-generation chips running in fifth-generation motherboards and the mixing of technologies between different chip families. AMD K6 and Celeron X86MX are considered to be the 6th generation chips, despite the fact that they run in 5th generation motherboards. This is based on assessing them technologically and in terms of their performance, along with when they were released to the market. Some of its examples are Intel Pentium Pro P6, Intel Pentium 2 Clamart, AMD K6 and Celeron X86MX. Types of server processors. There are basically two kinds of processors that are available in the market: ARM processors, x86 processors. They are ARM processors which are named after the company that designs and manufactures them, and x86 processors which are named based on the instruction set that they use. Devices that are small and battery powered use ARM processors, while devices such as laptops, desktops, and servers use x86 processors. The x86 types of processors are manufactured by AMD, Advanced Micro Devices, and Intel. To make machines run faster, manufacturers use a technique to increase output by placing more than one processor on a single chip. Each processor is called a core. 2 processors create a dual-core processor, and 3 or more create a multi-core processor. Features of server processor, processors, and power. A processor, commonly known as microprocessor or CPU, is the brain of a computer. Each time a cycle of electricity passes through the processor, it fetches instructions from programs and executes them. Faster processors have more cycles than slower processors, but also require more power and generate more heat. A 2.4 GHz processor executes 2.4 billion cycles per second. Power consumption is a primary consideration in the design of microprocessors because the battery-powered devices do not have a lot of power to provide for the processor, and it is based on the fact that there is a general desire to reduce power consumption for environmental reasons. Features of server processor, ARM processors. When you buy an iPhone, iPod, digital camera, or tablet, you don't have a choice of processor as you do when you buy a laptop or a desktop. Almost all small electronic devices with a microprocessor use ARM processors. However, not all ARM processors are the same. ARM licenses the design to manufacturers that may modify it before they manufacture the chips. ARM processors don't require much power to run, which makes them ideal for battery-powered devices. However, low power means low performance, and this limits their use to devices that do not need a lot of computing power. Features of server processor, AMD and Intel processors. When you buy or build a laptop, desktop, or server, you can generally choose a processor from either AMD or Intel. With the exception of the Intel Atom processor, used almost exclusively in netbooks, these processors require considerable electric power. Further, they provide correspondingly more computing power than ARM processors. Some AMD processors are faster than Intel processors, but there are some Intel processors which are faster than AMD processors. When you buy a computer, the processor is one of the several features that influence your choice. When you build a computer, you must choose a motherboard that is compatible with the processor you select. Features of server processor, multi-core processors. If you add another processor to a computer, you essentially have to add another motherboard too. A compromise is to place multiple processors on a single chip. The processors share the resources that the motherboard provides, such as access to memory. To the motherboard, it appears as though there is only one processor, but in fact, there might be 2, 4, 8 or more processors. Each processor is called a core, and the collection is called dual-core or multi-core processor. ARM, AMD, and Intel use this technique to increase output without increasing the number of cycles per processor. Difference between desktop processor and server processor. There are many differences between desktop processor and server processor if you view them from different perspectives. So some of the fundamental differences between the two are: desktop processor is designed for general consumers, while server processor is meant for specific and big consumers. Desktop processor is optimized for single processor use, while server processor is allowed to be used in groups. Desktop processor is not suitable for multi-threading, but server processor is better suited for multi-threading. Desktop processor generally has less cache memory, but the memory size of a server processor is huge. There are differences in the type of sockets for desktop processor and server processor. Conclusion. In this chapter, the users are covered following aspects of Pentium class processors: Pentium processor, Pentium Pro processor, Pentium Mmx processor, Pentium 2, Celeron processor, Pentium 3 processor, Pentium 4 processor, Introduction to Server class processor.